evaluating, we forgot to divide um, using h cube. So this h cube is the, well, let's not get into what it is. We all know what it is. Let's not go into the technicalities. So smallest phase space volume, we need to divide it, divide this d3q d3p using h cubed, right? And the rest remains the same. Also, notice here, I've told you guys that the integral is gamma half. Actually, this is not gamma half, it is gamma 3/2. Right, sorry. So that integral is gamma 3/2, which comes out to be root over pi by 2. So if we take these two things into consideration, then Z1 turns out to be m pi t to the power 3/2 divided by 2, and there should be an h cube. Right? So this thing comes out to be, so this is 2, right? So this is root 2 18 3/2 x cube. Right, so this should be the answer for question A. Now moving to question B. Here, what do we need to find? Let's go to the question. Yes. Now the classical partition, canonical partition function 7 for the indistinguishable particles. Note the particles are okay. Particles are indistinguishable. We need to find the classical partition function, canonical partition function for this system. Right. So let's get to it. It's really easy to solve. So the partition function for indistinguishable particles should be like 2n number of volume integrals. So we basically write it down. This is for particle 1 and particle 2, and it goes on Pn Qn. So this 2n number of volume integral, and yeah, and we'd have this factor as usual, and this thing would be dependent on P1, P2, Pn, 1, and if I have to factor this, like write this factor explicitly, let's do that so that we can easily evaluate this integral. This factor has no potential in it, but it does have the kinetic energy part, and for particle 1 that turns out to be this, and these are radical particles, so each one has indistinguishable particles, radical indistinguishable particles. These are, they all have mass m. This continues, and notice this, these integrals do not depend on it's a particle integral for particle 1. It does not depend on variables of particle 2. So what happens is we have bunch of independent integrals, which can be written down as following. Obviously divided by appropriate factors, which we were missing this time too. Let's not do that. And if we notice correctly, this is just a definition of Z1, and this is also Z1, and we have n copies of that, so it's about n. But we forgot one thing, that is these particles are indistinguishable, meaning all these ways of getting the energy E, right? Getting this energy E. So this thing is repeated in factorial times, so we have to divide it in factorial. There's a number of particles that's distinguishable. And, these integrals are nothing but like seeing how many micro states are possible for the energy E by varying the P's and Q's. So due to indistinguishability, we need to divide number of microstates using in factorial. And so Zn turns out to be this thing, and we all know what Z1 is. Z1 is this thing. If I have to copy it, let's do that. So add it to front page. This thing. So Z1 is that, and find at last ax h cube right. So this is Zn. Now moving to question C. What do we need to find this time? So the next question, we are told that the lid of mass spectrum is free to move vertically and is acted upon by a downward gravitational force mg. So the potential energy at height x is given by fx. Calculate the classical particle function of a system of n particles plus the lid. Integrate explicitly over the position and momentum of the lid. So now the lid, this thing, which was initially at height x, this thing is able to move up and down. Right, this thing is able to move up and down, and we are told to find the partition function for it. Again, see the question, so it's sure. Yeah. So it has a mass m, and it's being acted downwards by a force, gravitational force mg. It's standard. We find the partition function for this whole system of n particles, and it also. So that's quite simple. That is basically Zn systems total partition function is Zn times e to the power minus beta energy of the lid, right? And this is momentum of the lid and position of the lid. And this integral is run on these two points, and first possible volume is phase space volume is h. So divide it to this. Now Zn is Zn. It does depend on x actually, because Zn has integrals whose boundary is dependent on psi x. So this thing depends on x also. Have plus beta a led square by 2 epsilon plus the potential energy mg z. Z or x, let's use x. That's the variable we're using till now. And PL dx h. Now we know what Z and X is. Found it here. Let's write it down. 1 by factorial up to m pi by beta to the power 3 by 2 ax to the power n I believe. We have two integrals. Right. So let's evaluate these two integrals. Should be straightforward.